me that question, I can send you some resources. Yeah. Okay, so today we are covering day 1 in the Unit 8 content, my favorite unit. This is all about right triangles and different equations and theorems that we will use with right triangles. The first one should feel familiar, the Pythagorean Theorem. And we touched on the Pythagorean Theorem in the last unit when we had to find some missing angles in a rhombus or a square. And we're going to be using the Pythagorean Theorem even more in this unit. Hopefully it's not super new to you. We've learned the Pythagorean Theorem at one point in time, and we really use that to find the missing side of a right triangle. So to find the missing side of a right triangle. Okay, so that's very important. It has to be a right triangle. And what makes it a right triangle? Well, having a 90-degree angle. Okay. Typically, sides A and B are called the legs, and C is the hypotenuse. The hypotenuse is the longest side of your right triangle. It is always across from the right angle. Okay. So the side across from that right angle, that's your hypotenuse. The sides that touch the right angle are the legs. Okay. Now, for any right triangle, the Pythagorean theorem says a squared plus b squared equals c squared. This is probably how you learned it. I'm going to flip it around using my symmetric property, and I'm going to start using the Pythagorean theorem as c squared equals a squared plus b squared. And you'll see why when we get a little bit further into today's lesson. Okay. So either one of these will work. Okay. I like the one here in red, and you'll see why once we get to that part of the lesson. Okay. It's only right for right triangles. Okay. All right, so let's practice using the Pythagorean theorem. We're just going to do 2 of these examples, and then we will move on just to brush up off some of the cobwebs from learning this a long time ago. I personally like to label my sides A, B, and C. The hypotenuse will always be C, so that's the side across from the right triangle, so that would be C. Then I like to make the smallest leg A and the larger leg B. So it's like A, B, C, small, medium, large. It's just how I always do it, so that way I stay consistent every single time. The Pythagorean theorem says c squared equals a squared plus b squared. So c in this case is x, a is 8, and b is 13. Now I still have to square those, so 8 squared plus 13 squared. You can just type that straight into your calculator. So if you're using Desmos, 8 squared plus 13 squared. If you need help finding that square button, it's a good idea to click on it's a little button that looks like a keyboard. When you click on that, all of these new buttons will pop up for you, including the square. So when we do 8 squared plus 13 squared, we end up with 233. Okay. And we talked about how to undo a square. Was it last class? Last time we were live? And to undo a square, that's the square root. Okay. Very good, Hannah. Thank you. Good job, John. Yes, you're right. Square root. So the square root of x squared is just x, because a square root undoes the square. So then we look at our calculator, we say, hey, calculator, what's the square root of 233? And the directions will tell you what to round to. Most of the time it's to the nearest tenth. So to the nearest tenth, we've got 15.3. Okay, so that's when x is your hypotenuse. Now, the Pythagorean theorem still helps you find a side of a right triangle, even if x is a leg. So I'm going to skip down here to example 3. In example 3, which value here represents the hypotenuse? Before you answer here, I'm going to try something new here. If you would, you should be able to use your pointer tool. Can you point to the hypotenuse in number 3? Look at all those pretty colored arrows. You guys are brilliant. You're right. 9 is the hypotenuse. Thank you so much. Okay, so 9 is the hypotenuse. Oh, look, my pointer just turned a different color. That's cool. All right, so I'm going to label that C. Now, A and B are the legs. So in this picture, X looks like A and 7 would be B. If you had those mixed up, it doesn't matter. A and B just have to be the legs. I could have made 7A and XB, and it's not going to change my equation since addition's commutative. But I usually like to make the shorter leg A and the longer leg B. Yeah, if you're on a phone or an iPad or something that's not a computer, those tools, the whiteboard tools, can be a little weird. So for C squared equals A squared plus B squared. C in this case is 9. A is the missing side, so I'm going to call that X, and B is 7. So now we got to do a little bit more algebra than we had to do in example 1. 9 squared is 81. I don't know X squared, so I'm going to leave it X squared. 7 squared is 49. So to get that X squared by itself, we're going to subtract 49 from both sides. 81 minus 49 is 32. So I get 32 equals X squared. And now I can do the square root step. So the goal is to always get that X squared by itself. And the square root of 32, Nashmia, you are correct. It's about 5.7. Okay, so whether your missing side is the hypotenuse or a leg, this Pythagorean theorem will be your friend. And I'm going to let numbers 3 and 4 just be some practice problems for you to do later. Let's look at an example where it's not as obvious, but Pythagorean theorem can still be good. All right, so let's look. Let's look at number 5. In number 5, I have an isosceles triangle. Okay, I know it's isosceles because it has 2 congruent sides. And I see that the altitude there is X. So if I were to redraw half of this guy, whoa, let me try that again. There we go. Where I know this is X and this is 24. What would be the length of the base? Go ahead and type that in the chat. What do you think will be the length of the base of my redrawn triangle? Yeah, it's 11, half of 22. And now we can use our Pythagorean theorem. We know that the altitude of an isosceles triangle is in fact perpendicular to the base. And if you didn't know that, now you do. So let's use our Pythagorean theorem. C squared equals A squared plus B squared. In this case, C is 24. That's the longest side or the hypotenuse. A is the shorter leg, which is, I'm going to say, is 11. And our missing height or missing leg is X. So then we'll say, okay, well, 24 squared, 576. 11 squared, 121. And now I'm solving for X, which means I need to get rid of this 121. So subtract 121 from both sides. And to undo my square, I'm going to square root. Make sure that you can get the answer on the calculator. 21.3, good job. Make sure that you can get 21.3 on your calculator. Okay. I'm not going to go through all of number 6, but let's just kind of think about how we would do it, right? This isn't a triangle, but what I could draw in this line, and now I have a right triangle. Right? If I were to redraw it here, this length would be the same as this length, so this is X. The hypotenuse would be 16. What do you think would be the length of this leg up here at the top? It is a trapezoid, you're right. It's not 9. Oh, Heather, I like what you typed there. You're right. Yeah, if you typed 13, I agree with you. Because down here is 5, that means up here is also 5. And if the whole thing is 18 and that little piece is 5, then this missing piece over here is 18 minus 5, or 13. And then we can use the Pythagorean theorem to solve for x. So that's just kind of helping you brainstorm your way through how you would set up this problem. I'm going to let the actual solving part be up to you. I want to look at number 7. Number 7 is a lot of fun. In number 7, I actually see 3 right triangles. We're going to work with the 2 smaller ones. So let's look at the smaller one right here, and I'm going to redraw it as best I can. There we go. I know that this length is 12 and the hypotenuse is 14, and I don't have anything to label this bottom leg yet. I'm just going to wait just a moment because I'm going to redraw this one over here. Okay, here it is. The hypotenuse there is 29. This is still 12. That was the shared side. And I don't have anything to label this bottom one yet. However, now we can find this bottom piece right here, right? I'm going to call this piece z, just for a different variable. And I'm going to call this piece down here, not x, because x was already used. So I'm going to use y. And then at the very end, to find x, right? This was y and this was the z. I can just add my y and my z together, and that'll tell me the entire length of x. Very good, Haley. You're right. So you know what? Let's try this one on our own. I want you on a piece of paper, a wipe-off board, whatever you have there that you can write with, find the value of y, and then find the value of z. And then once we have those, we'll easily be able to find x. You don't need to type them in the chat. I'll give you a few minutes to work on it. When you are finished finding y and z, give me a check mark. Okay, so don't give me a check mark and wait until you found y and z. And once most of us have finished finding y and z, then we will move on. Okay, so let me know once you found y and z. Cool. If you are just joining us, we are working on number 7. If you need to move the poll out of the way, you're welcome to do that. We are finding the length of y and z using the Pythagorean theorem. once you have your answer for y and z, you can go ahead and add them together to find the length of x. And then give me a green check mark to tell me you're ready to move on. Don't give me an X because I don't know what that means. The check mark is just to tell me that you are ready to move on. You can round to the nearest tenth. That's fine. The nearest tenth is good. Ooh, Haley. Impressive with the like approximate symbol. Nice. All right, let's go over it. Most of the answers I saw in the chat were right. I just want to make sure that I'm going over it for anyone who might be stuck and just not answering me in the chat or on the poll. Yes, Hannah, that's right. So for y, you should have gotten about 7.2. So the setup for this would look like 14 squared equals y squared plus 12 squared. 14 squared is 196. 12 squared is 144. And you're going to subtract 144 from both sides. So you get 52 equals y squared. And then you'll take the square root of both sides. And the square root of 52 is about 7.2. And then let's look at z. So for z, we would have 29 squared equals 12 squared plus z squared. And if you had your z and your 12 flip-flopped, it's not going to change your answer. 29 squared is 841. 12 squared again is 144. Subtract 144 from both sides. You get, what do we get? 697. And then take the square root of both sides. And the square root of 697 is about 26.4. So now to find our final answer, right, this is something that a quiz would do, right? They would ask you to find x, and then you find all these beautiful numbers. Make sure you actually answer the question. X is the sum of that y and that z. So if you told me in the chat that x was 33.6, you were right. You're going to add that 7.2 and the 26.4. Okay. Now these types of problems can be shown to you in many ways. So like here, number 8 and 9, they look a little different, right? And number 8, if I wanted to find x, well, I would need to know this missing side first on this bottom triangle. So what I can do is I can use the Pythagorean theorem in the bottom triangle to find the missing leg, and then use that leg to help me find this missing leg. There's quite a few examples like this, on future things, whether it's an assessment or another word problem or something. So let's just do number 8 together, and then we'll move on to word problems. Okay. So I like to give this missing side, I know I need to find this side. It's not labeled with anything, so you can give it a different variable. Don't use x, because x is already up here, and you don't want to get your two x's confused. So I'm going to choose y because I'm boring. Now, if you wanted to choose m or q or w, whatever. I don't recommend O, and I don't recommend L, but whatever variable you want. So then what we're going to do here is I'm going to look at this bottom triangle. In this bottom triangle, the hypotenuse is 25 and the legs are 10 and y. So 25 squared becomes 625, and 10 squared, of course, is 100. Oops. Why did I do that? That's silly. Subtract 100 from both sides. And then to undo my square root. So this becomes about 22.9. Now that I know what y is, it's about 22.9. I can look at the top triangle. In that top triangle, the hypotenuse is 28, and the legs are x and 22.9. And I'm not going to write 22.9. I'm going to write y squared for a moment, even though we know what y is. You'll see why in just a second. 28 squared is 784. Now, if I take 22.9 and square it, right, 22.9 squared, I get 524.41. But that was a rounded answer. This 22.9 is rounded, right? So I want a more exact answer. And what I'm actually going to do is go back to this step where it said that y squared equaled 525. So I'm going to write 525 right here because y squared equaled 525. We didn't do the rounding until we took the square root. So by putting this 525 right here, I'm making my x value more accurate. If I put 524 here, that's going to change the x value enough to not be as accurate. Okay, so are we okay with how I put 525 here for y squared? Yeah. Okay. Now I can subtract 525 from both sides. So 784 minus 525 is 259. And now I take the square root. By making that y squared 525, I have allowed myself to only round one time. If I'm rounding at one step and then rounding at another step, and then, oh my gosh, if I round in another one, my answer is becoming less and less accurate. So if you can save yourself rounding until the very, very last step, that'll make your answer as accurate as possible. So you should get, where am I here? 16.1. I'm not going to go through all of number 9 here with you, but we can do a little brainstorming here together. Clearly, we see a right triangle right here. I'm going to redraw it. We know that the height of that is x. What would be the hypotenuse of this right triangle? What do you think? Yeah, it's 20. It is. You're right. Yep, John, you're right. That's true. It doesn't say it's a square, though, so we got to be careful with that. So now the hypotenuse is 20. So now can we figure out the length of this bottom piece right here? Okay. Well, if this is 26, that means from here to here is 26, right? So if I do 40 minus 26, I get 14. Okay. So between these two pieces, this piece here and this piece here, they have to add up to 14. And they're the same length. So if I have two pieces, they add up to 14 and they're the same length. You're right, Haley. 14 divided by 2. These will each be 7. So that bottom piece is 7. And now we just play the Pythagorean Theorem game. Isn't that fun? Why do they have to be the same length? They have to be the same length because these two triangles, let's see, I'm going to make them in green. This triangle over here and this triangle over here are congruent. And so their corresponding parts have to be congruent. Yep. No, that was a really good question. Okay. is with this arrow right here? I don't get it. Oh, well. Okay, so Pythagorean theorem questions are also really good word problems. And the trick to these word problems is, just, can you sketch the picture? Clearly, I am not an artist. I know you guys have seen some of my drawings. Not an artist. Not like Axel. Are you still in here? But I can sketch a picture, right? So a roofer leaned a 16-foot ladder against a house. Okay, so we're going to draw a house. And I wouldn't spend a lot of time drawing your house. Like, here's my house. Woohoo! I think my daughter can probably draw a better house, but that's okay. And he's going to lean his ladder against the house. So draw your ladder. Whoop, there's your ladder. You can even like make it look like a ladder if you want to. Yeah, a greenhouse. Okay, and now it says the base of the ladder is 5 feet from the house. So here's the base of the house. Here's the base of the ladder. So that length is 5 feet. How high up the house does the ladder reach? Okay, so how high up the house? That's right here. That's what I'm looking for. So we'll call it X. And there's one more number to put in my picture, and that's 16. That's 16-foot ladder. Yes, the classic ladder question. You're right, Max. All right, now there's one thing that you kind of need to assume, and I'll tell you it's okay to assume it in these types of problems, is that your house makes a 90-degree angle with the ground. Okay. Once you can draw that picture, or at least get an idea what the picture should look like maybe you just draw a triangle because you just don't even want to draw a house. Okay, whatever. As long as you know what your hypotenuse is and your legs are, then you're good. So now that you have your picture, just set up your Pythagorean theorem. C squared equals a squared plus b squared. So C is the hypotenuse. We'll make A 5 and B x. And if you had your 5 and your x flip-flopped, not a big deal. Okay, so now 16 squared is 256. 5 squared is 25. Subtract 25 from both sides, 231. And to undo a square, square root. Please make sure that to undo a square, you are using the square root button. Sometimes students get confused and they want to divide by 2. That will not get you the right answer. So remember, to undo a square, square root. So the height of that ladder against the house is about 15.2. 16.8, how'd you get that? Make sure I did this right. Square root 231. Yeah, 15.2. And the units here, now because it's a word problem, right? It's a length, so our units are going to be feet. All right, let's look at number 11. Number 11 uses properties of quadrilaterals. Kind of. Yeah, it does. All right, Kurt is building a rectangular deck. So let's draw a picture of his deck. Bird's eye view. Rectangular deck. The dimensions of the deck are 10 feet by 23 feet. So 10 feet by 23 feet. What is the length of the diagonal? And so from here to here. What is very important about this is it's a rectangle. Why do I care that it's a rectangle right now? What property of a rectangle? Yeah, Lydia, you know it. What property of a rectangle is going to be key to being able to solve this? Well, if I want to use the Pythagorean theorem, what do I have to have? Pythagorean theorem says that you absolutely must have what shape? A right angle. So how do I know that I have a right angle right here? How do I know that's a right angle? Because rectangles have 4 right angles. Exactly. Who said that? Rashmia, you're right. And Haley, very good. Yes. So why was it important it's a rectangle? Well, it's important to be a rectangle because rectangles have 4 right angles. So as soon as I know that's a rectangle, boom, I've got a right angle there. And now all I really have to worry about is my right triangle. I'm finding the length of the diagonal of the rectangle, which just so happens to be the hypotenuse of this right triangle. All right, so c squared equals a squared plus b squared. Do you have to write that every single time? No, but if it helps you, absolutely, go for it. In this case, my hypotenuse is x. My legs are 10 and 23. So I can just type 10 squared plus 23 squared in my calculator. 629. So when I take the square root of both sides, we get about 21.5. Very good, Nishmia. Did I say that right? 25.1. And my units here are going to be feet. It's a length in feet. All right, I want to do one more. One more word problem, and then I'll let the word problem, last one, be for you. Okay. Ashley jogged 3.4 miles east and then 5.7 miles south. Okay. If you need to like draw yourself your little compass rose, maybe you forget it or whatever, you're welcome to do that. Right? Remember north, south, east, west. So give Ashley a place to start. She's going to start right here. And she's going to jog 3.4 miles east. So she's going this way for 3.4 miles. And then for some reason, she's like, you know what? I'm tired of going east. We're going to go south now. So then she goes south 5.7 miles. So now Ashley is down here. Okay. She's a very talented jogger where she made an exact 90-degree turn. How far from her starting point is Ashley? So what part of my triangle are we trying to solve? What part of the triangle are we trying to solve for? We're trying to find h, the hypotenuse. Very good. You could call it h if you wanted as the variable. No one says the variable has to be x. I like x, so I'm going to use it. But you could call it an h if you wanted to. And now we find that length. So c squared, you could even call it c if you wanted, equals a squared plus b squared. Okay, in my calculator, I'm typing 3.4 squared plus 5.7 squared, and I get 44.05. Take the square root of both sides, and 6.6, yeah. If you said 6.6 down there in the chat, you're right. She's about 6.6 miles from her starting point. Okay, so if she wanted to just jog right back to her starting point, she'd have to go 6.6 miles. Before we move on too much further, I'm going to give you your attendance word. Here you go. Your attendance word today is south. Yeah, that one was not a predictable word, was it? Your attendance word today is south. Write that down, highlight it, circle it, do the hokey pokey, and then do the attendance quiz. Yes, assuming the ground is flat and you took no turns. Yeah, we have to do a lot of assuming things here. Brayden, you're right. Okay, so south, you got that written down? We are going to move on. Let's see. You know, I'm going to give you some time to work on number 13. I want you to practice number 13. Draw yourself a picture. You got a 31-foot support wire attached from the top of a 25-foot telephone pole. How far from the pole's base does the wire meet the ground? Try sketching your picture. And then once you have an answer, go ahead and type your answer in the chat. Yeah, I'd like to see what you get. Round to the nearest tenth. And I'll give you, let's do 3 minutes. 3 minutes, maybe 4 if we need it. Let's try number 13. I'm seeing a lot of really good answers come in the chat. I'm seeing a couple incorrect ones come too. And I just want you to double check how you set up your equation. The 31-foot support wire, that's representing your hypotenuse. The 25-foot pole is representing your vertical leg. You are looking for the horizontal leg. So double check that setup. If you didn't set it up that way, I'm guessing that's probably how we're coming up with a 39.8. Okay. Yep, that's okay. That's what we're here to do, is to make mistakes and learn from them, right? I'm just going to put the rest of my answer here on the board, and then when you're done, you can check it. Hannah, I see that. All right, so you should have gotten 18.3 feet. If you said 18.4, I'm going to just caution you to be very careful with your rounding. So be very careful with rounding. If you said, what was that one I kept seeing? 39. If you said 39.8 or something like that, I'm guessing you probably just set it up wrong. So just double check the setup. All right, nice. So that was all kind of review from like middle school, right? So why are we doing that now? We're going to add on to the Pythagorean theorem a little bit. And what we're going to do actually is we're going to use this Pythagorean theorem to actually help us determine not only things if it's a right triangle, but it could actually tell us whether the triangle is acute or obtuse. And here's what we're going to do. And this is why I was writing it c squared. If your c squared, instead of being equal, is actually less than a squared plus b squared, you no longer have a right triangle. What you actually have is an acute triangle. Of course, c squared equals a squared plus b squared. That's your right triangle. And if c squared is greater than a squared plus b squared, then your triangle is, you've probably already guessed it, obtuse. This is why I was writing c squared on the left, or starting with c squared, because when I think of acute, I think of less than 90. So I can associate that less than symbol with my acute. And when I think of obtuse, I think of greater than 90. So I can think of my greater than symbol to go with obtuse. Okay, so rule of thumb says if c squared is less than a squared plus b squared, you've got an acute triangle. And if c squared is greater than a squared plus b squared, then you have an obtuse triangle. And of course, the right triangle is what we've been working with. If c squared is equal to a squared plus b squared, then we've got a nice right triangle. Okay, so I would definitely put these on some flashcards maybe. Right, on one side, acute triangle, and then the blue equation. Maybe in one side, right triangle, and then the Pythagorean theorem. And on one side, obtuse, and the other side, c squared is greater than a squared plus b squared. One thing that we do have to be careful of is we have to make sure that the triangle that they're asking us about actually exists. Okay, so we need to review that for a moment. We learned, way long ago in semester 1 at one point, that a triangle exists when the small side plus the medium side is greater than the large side. Hopefully this is ringing a bell. Right? And so because the small side plus medium side is greater than the large side, the triangle existed and it was great. Well, we need to make sure that this triangle even exists before we can test whether or not it's acute, right, or obtuse. So you should always test, does the small side plus the medium side, is that actually greater than the large side? Well, 3 plus 7 is 10. 10 is greater than 9. So yes, this triangle does exist. So the not a triangle is not going to be an option. Now we need to know, is it acute, right, or obtuse? And here's how I set that up, right? I'm going to set up c squared, and I'm going to just leave a box because I don't know if it's greater than, less than, or equal yet. A squared plus B squared. So in this case, C would be the biggest. So C is 9. Just a box, a blank. You don't know what symbol goes there yet. A is 3 and B is 7. So 9 squared is 81. I've run out of space here. And now in my calculator, I'm typing 3 squared plus 7 squared. 3 squared plus 7 squared gives me 58. Now that I know my numbers, I know which symbol to put in that box. Am I going to put a greater than, a less than, or an equal sign? What do you think? Yeah, I'm going to put a greater than. You're right. And so because I have a greater than, I can now determine that this triangle is in fact obtuse. Okay, so when solving a problem like this, first double check the triangle actually exists. Then use your Pythagorean theorem to determine, is c squared actually less than, equal to, or greater than a squared plus b squared. So let's look at number 3. I want to do number 3. Okay, let's first test, is it a triangle? So to determine whether or not it's a triangle, you have to add your small and your medium sides together, and they have to be greater than the large side. Is this a true statement? Clearly it is not, right? 15 is not greater than 16, not true. So right away, this triangle doesn't even exist. Not a triangle. If I hadn't done that step, I would now still be doing like 16 squared is something to 4 squared plus 11 squared, and I would be picking the wrong answer. So you got to make sure the triangle actually exists before moving on. Okay? Let's do number 2. And then I'll let you do number 4. Let's do number 2. We got to test, does the triangle exist? So does the small plus the medium side, is that actually greater than the large side? Oh yeah, this one definitely is, right? 41 is definitely greater than 29. So this is a triangle. It exists. And now we need to test, does c squared, and if it helps you to like label these A, B, C, be my guest. That's great. C squared is something to a squared plus b squared. Well, 29 squared is 841. And 20 squared plus 21 squared, you can type that straight into your calculator. You get 841. So I'm going to put a handy dandy equal sign in there. They're the same number. And when they are equal, it's a right triangle. Okay, so if it's not a triangle at all, then your triangle inequality will not hold. If it's acute, c squared is less. If it's right, c squared is equal. And if it's obtuse, c squared is greater than. All right. I'm going to put a poll up here on the board. We're going to make not a triangle A, acute B, right C, obtuse D, and E, I'm not paying attention. Go ahead and do number 4 and tell me what answer you got. Oh, I guess there is no E. Good. Tell me, what do you get? A, B, C, or D? Not a triangle, acute, right, or obtuse? What kind of triangle do you see there in number 4? I don't think it could be all of the above there, Max. That'd be kind of weird to be acute, right, and obtuse at the same time. If you are stuck, start by testing. Does your small plus medium side, is that greater than the large? If it is, then you can knock out one choice already. Let's do one more minute and then we're going to go over it. All right, nice. Anyone else want to answer there before we close the poll? Faith, you're right. Okay. If you said B, acute, you were correct. If you didn't say B, you definitely want to pay attention to this explanation here. Okay, so step one, make sure the triangle actually exists. So the small and the medium side, well, they're actually tied. So, you can make this 17 small and that 17 medium. It wouldn't matter. Just add those two together. They have to be greater than 22. They are, what is 17 plus 17? 34. 34 is indeed greater than 22. So this triangle exists. So that knocks out A. Okay. Now we need to decide A, B, or B, C, or D. Well, A, B, C. C is 22 for sure. So we're going to say 22 squared is something to 17 squared plus 17 squared. Well, 22 squared is 484. And 17 squared plus 17 squared is 578. And if just pushing the buttons on the calculator is what threw you off there, please let me know. I can help you with that. I don't want the button pushing to be what messes you up. And now we can decide what symbol goes in between. Is 484 less than, greater than, or equal? Well, clearly it's less than, right? And so because it's less than, we choose acute. And as long as you're setting it up with the C squared on the left and the A squared plus B squared on the right, this trick will work. Less than acute, greater than obtuse. There are 4 more examples here for you to practice, and the key for this is posted to OMHS, so you are welcome to practice these and check them on your own. Hopefully you find them fairly simple, but if you do have questions, please email me, let me know, and I will be in office hours on Tuesday if you want to join me then. There's an exit ticket for today on OMHS, so make sure you do that. Don't forget that. And don't forget to do the attendance quiz. That's all I have for the day. All right, don't forget to do the review for Unit 7 and do your Unit 7 test. If you are missing your Unit 6 test, those have already been entered as zeros. So if you are missing Unit 6, you want to make sure you definitely get that in. Haley, you always ask me. I should really just start looking that up. Give me a second, Haley. I'll look it up. If you have any questions, I'll hang out here for a couple more minutes and happily answer any questions that you have. Thank you, Cassie. Well, let's get on that, Nivira. If you need help finding the review, let me know. Haley, the answer to your question is 30 math questions. 31 total, because that first one is the, I'm not going to cheat question. So technically 31, 30 of those are the actual content. Thanks, Brayden, you too. Oh, thanks, Navira. It means a lot that you remembered. Thank you.